Bismillahirrahmanirrahim. I am Fazal Rehman. Well, we are going through the online teaching of mathematical methods 2 for physics BS 4 years and MSc students. I have already given you some material to study on the elementary differential equations. So that chapter is not yet completed because difficult portion is there, and we might complete it by taking live lectures. But there is another important chapter which is on the Fourier series. So I'll start with the Fourier series. Okay, so what I'll do, I'll try my maximum to clarify the concept. Now I'm writing on the board a series that is summation n is equal to 0 to infinity an cosine of nx plus bn sine of nx, and of course there is a constant term here a naught over 2. Now under normal condition it is a trigonometric series because you can see that there are cosine terms and sine terms. We don't call it Fourier series, but under certain condition it becomes Fourier series. And in fact there are many functions which can be expressed in terms of Fourier series. Now if you are asked to expand a given function fx in terms of Fourier series, then fx should be number 1 periodic, number 2 continuous, except for small number of discontinuity. Okay, now if that is so, and if you express that in terms of this series, then this series becomes Fourier series. Otherwise it is periodic series. It is a trigonometric series. Okay, so in these problems what you have to do, you have to find the coefficients a naught for every function an and bn. Once you find these coefficients, then you can put them in equation number 1, and what you get is the Fourier series of a function. But the question is that how to calculate these Fourier coefficients, which I have written there as a naught, an, and bn. Okay, now that is calculated as, I'm going to write it, that these are Fourier coefficients. Fourier coefficients. Now the value of a naught is given by 1 over pi minus pi to plus pi fx dx. The value of the second coefficient an is given by 1 over pi minus pi to plus pi fx cosine of nx dx, and bn is given by 1 over pi minus pi to plus pi fx sine of nx dx. So these are the three coefficients which are given by the expression, provided that the period of given function is 2 pi, that is minus pi to plus pi. Okay? Now I can explain that by giving you an example. Okay? Now if you come to suppose somebody says, okay, fx is equal to x minus pi, 0 is less than x less than pi, and minus pi is less than x less than pi. Period is 2 pi. Now this is an example. This is an example. Now what first thing you have to do is to plot the graph of the function. Now graph starts with minus pi and it goes up to pi, so that it covers a period of 2 pi. Okay? So that is your x, that is your fx. There is minus pi, there is plus pi. Now you can say that when x is 0, what is fx? 0. When x is pi by 2, here then fx is also pi by 2. When x is pi, fx is pi. So your graph is that. In the other interval, when x is 0, this is minus x. When x is 0, fx is 0. When x is minus pi by 2, it is plus pi by 2. When it is minus pi, it is plus pi, and graph is like that. Now we have plotted the graph of the function in the period 2 pi. Now you can extend this graph from pi to 3 pi. So this is 2 pi and that is 3 pi. It will repeat itself. Look, starting with 0 up to maximum, then it will drop, and then again it will go up to maximum. Similarly on this side, it is minus 2 pi and minus 3 pi, and you will have, so this is periodic repetition of the function, and you can see that function is symmetrical about y-axis. Now remember, any function which is symmetrical about y-axis, an even function. Even function is a function symmetrical about y-axis. Y-axis. On the other hand, if this function was like this, fx is equal to x minus pi less than x less than pi, then look what is the graph. Now here, start with minus pi, it goes up to pi, and function is x. Let's see what is its graph. Look at the mathematical form of the function. It is same, but look, their graph will be different. So what you start? Starting with x is equal to 0 up to pi and then up to minus pi. When x is 0, fx is 0. When x is plus pi by 2, it is plus pi by 2. When it is plus pi, it is plus pi. When x is minus pi by 2, fx is minus pi by 2. And when it is minus pi, then this is minus pi, and graph is like that. Now the same graph will be repeated further from pi to 3 pi, like this, and from minus pi to minus 3 pi, like this. Look here, one empty, and look at these graphs. Now these graphs are not symmetrical about y-axis. Now when we say symmetrical about y-axis, mean that this is mirror image of this. Now this is symmetrical about the origin. Okay? This point is reflected here and this point is reflected here. So this is an odd function. Okay? Odd functions, they are symmetrical about the origin. Origin, all right? And mathematical test is that if you replace f by minus x and your function does not change, then it is even function. Even function. On the other hand, if f of minus x is equal to minus fx, then that is an odd function. Okay? So, if your function is given in this form, then this is an even function, and if it is given in this form, then that is an odd function. Now keep that even and oddness of the function, and let's come to the Fourier series. Now I told you that in order to find the Fourier series of any fx, whether it is even, whether it is odd, or whether it is not even and not odd, we have to calculate the these coefficients. Now look, if fx is even, if it is even, then its value is given by 2 over pi 0 to pi fx dx. An is 2 over pi 0 to pi fx cosine of nx dx, and Bn is 0. This is when fx is even. When fx is odd, then a naught is 0, an is equal to 0, and Bn is equal to 2 over pi 0 to pi fx sine of nx dx. Now these are the coefficients you have to calculate for odd function. So you will check it by plotting the graph whether function is even or odd. Once you have decided it is even, then you don't have to calculate this is 0, and you have to calculate only a naught and an. But if you plot the graph and graphs come like that one, that is it is odd function, then its two coefficient a naught and are 0. You don't have to calculate it. You just calculate Bn. Okay? You just calculate Bn. Now see why it is. Now when fx is even, then and if you integrate the even function between symmetrical limits, that is same limits, with opposite signs, then it is always 2 over pi, that is 2 times the same integral. Now, since your given function, we have assumed it is fx is even, cosine minus theta is cosine theta, which is also even. So even into even is even, and hence it is 2 over pi fx cosine nx dx. And since fx is assumed to be even, sine nx, because if you replace x by minus x, you get minus sine x. So this will be odd, this is even. Odd into even is always odd. So this integrate is the odd and result is 0. Now if you come here, when fx is odd, then this is odd function, and for any odd function between symmetrical limits with opposite sign, fx dx is 0 integral, and therefore a naught is 0. Since fx is odd, cosine nx is even, that is odd, and result is 0. fx is odd, sine nx is odd. Odd into odd is always even. Okay? So odd into odd is even. Odd into odd is equal to even. And hence this is an even integrand, which can be written as 2 over pi 0 to pi integral fx sine nx dx. Okay? Now we come to our example. Okay? So let me write, let me solve these both of them. I am going to calculate what is a naught, an and bn. But we see that this is an even function, hence we don't have to calculate bn. We have to calculate a naught and an. Okay? So this is what we are going to do. Now how we'll do it? A naught is equal to, because it is an even function, 2 over pi 0 to pi, what is your fx? X dx. Integral 2 over pi is out, x square over 2, 0 to pi. So it is 2 over pi, pi square over 2, 2 to cancel. So your answer is pi. Right? The other limit will give you 0. So your a naught is, what is your a naught? A naught is pi. So what we have calculated, for this a naught is equal to pi. That is one thing we have done. The second thing, it is an, which is, because it is an even function, so it is 2 over pi 0 to pi fx cosine nx dx. So let's calculate it. This is just matter of calculating integral. An is equal to 2 over pi 0 to pi fx is x cosine of nx dx. U into v form. So it is an is equal to 2 over pi u integral of this, how much? it will be sine nx over n, and limit is 0 to pi, minus integral 0 to pi, derivative of this 1, integral of cosine nx, which is sine nx over n dx. Now, if I substitute the limit in this part, you see sine n pi is always 0, and when you put 0, sine 0 is 0. Hence, this portion is 0. Okay, so we don't want it. And your an will be equal to, minus is here, minus 2 over pi, n is there, and your integral is 0 to pi cosine of nx dx. Now, if you integrate it 2 over n pi, it is minus sine nx over n 0 to pi. Minus sine nx, I'm sorry, it was sine nx. It was sine nx. Okay. So its answer is minus cosine nx over n. Now minus minus become plus 2 over n pi to n square pi, because this is n square, and that will give you cosine n pi minus cosine 0. Now, cosine n pi is minus 1 raised to the power n, and that is 1, okay, and that is equal to 2 over n square pi. When n is even, okay, I am here. When n is even, then an is equal to 2 over n square pi. This will be plus 1, this will be minus 1, and an is equal to 0. But for n is odd, an is 2 over n square pi. If n is 1, it is minus 1. N is 3, minus 1. N is 5, minus 1. So minus 1 and minus 1 is 2. So it is minus 2. And your answer is minus 4 over n square pi. That is your an, but when is odd. And I told you, okay, when fx is even function, then its bn is 0. So a naught is that an is equal to minus 4 over n square pi, and n is odd, right? Because for even that is 0, and bn is already 0, right? So we have 3 coefficients. We have calculated the 3 coefficients. So your fx, function fx is equal to, your function fx is equal to, your function fx is equal to a naught over 2. A naught was pi, so it is pi over 2, plus summation n is equal to 0 to infinity. An is minus 4 over n square pi cosine n x. This is an, that is cosine nx, plus bn is 0, that is 0. Remember, n is equal to 0 to infinity, but it should be odd because for even an coefficient is 0. So your Fourier, what is your Fourier series? Your Fourier series is now the following. Fx is equal to pi over 2 plus n is, because odd will start with 1. Okay? So it is, when you say 1 cosine x, okay, and that is minus, you can take this minus 4 over pi common, and what you minus 4 over pi is common, so you have cosine x over 1 square plus n is 3, then cosine 3x over 1 raised to the power 3, n is 3, plus cosine 5x over 5 raised to the power, sorry, this is not 3, this is 2, 3 raised to the power 2, this is 5 raised to the power 2, and so on. So this is the Fourier series of fx for that one. Now if it is said, okay, now find the Fourier series for this one, that is this function, you have seen that that is the Fourier series, so similarly we will calculate the 3 coefficient, but now it is easy for us because function is odd and 2 coefficients are 0. So for the second example, for this case, a naught is equal to 0, a n is equal to 0, and bn is equal to 2 over pi, 0 to pi, fx sine nx dx. You know, I have erased that thing. You will see if you go back, you roll the film back and you will get that. And in that case, bn is equal to 2 over pi, 0 to pi, x, fx is x, sine nx dx. Again, u into v form, it is equal to 2 over pi, which is outside, u, which is x, integral of this minus cosine nx over n, 0 to pi, minus integral derivative of x is 1 and integral of sine nx is cosine nx over n dx. Okay? Or bn is equal to, let's substitute the limits. When it is pi, 2 over pi, pi minus cosine of n pi over n, minus x is 0, it is 0. And I am not calculate this integral. Why? If you integrate, then this will become cosine nx over n square, and sine n pi is 0 and sine 0 is 0, so that is gone. You don't need that. So that is also 0. That is 0. And your bn is equal to your bn is equal to minus 2 over pi into pi cosine of n pi over n. This pi cancels, and that